Every year, dozens of aircraft vanish over water, swallowed by an expanse so vast it could hide entire cities. The ocean covers 71% of Earth's surface, and when something goes wrong at 35,000 feet above it, the mathematics of survival change completely. What makes the ocean the most dangerous place for a plane to disappear? Since commercial aviation began, more than 100 aircraft have been lost over oceans, with wreckage sometimes taking years to find or never found at all. These aren't just old propeller planes from the 1940s. Modern jets equipped with satellite tracking, emergency beacons, and reinforced black boxes still go missing over water with alarming regularity. The question matters now more than ever because air travel over oceans is expanding rapidly, with new ultra-long routes connecting continents across the Pacific and Atlantic. Understanding why the ocean swallows planes helps us prevent the next disappearance. The pattern begins long before the jet age. In December 1945, 5 U.S. Navy torpedo bombers known as Flight 19 disappeared over the Atlantic during a training mission near Florida. The 14 crew members were never found. The rescue planes sent to look for them also vanished. Decades later, the ocean proved it had lost none of its capacity to hide wreckage. On June 1, 2009, Air France Flight 447 dropped from the sky over the Atlantic while flying from Rio de Janeiro to Paris. All 228 people aboard died. Despite an immediate international search effort covering thousands of square miles, it took 5 days just to find the first floating debris. The black boxes, designed to emit underwater locator signals for 30 days, were not recovered until nearly 2 years later. They were found resting on the ocean floor at a depth of nearly 13,000 feet, beyond the reach of most search equipment. The investigation revealed that ice crystals had blocked external speed sensors, confusing the pilots about their actual airspeed in a storm. Then came the case that changed everything we thought we knew about tracking aircraft. Malaysia Airlines Flight 370 disappeared on March 8, 2014, while flying from Kuala Lumpur to Beijing. The Boeing 777 carried 239 people. It vanished from civilian radar over the South China Sea, but military radar later showed the plane had turned back, crossed the Malay Peninsula, and flew south into the Indian Ocean for hours. How does a modern airliner simply disappear in an age of GPS and constant connectivity? The answer lies in a gap that shocked the aviation world. Flight 370 was not being tracked continuously. Once beyond land-based radar range, the only way investigators could trace its path was through automated hourly handshakes between the aircraft and a satellite. These weren't GPS coordinates. They were simple electronic pings that could only estimate a general arc of possible locations, stretching across thousands of miles of open ocean. The main underwater search covered 46,000 square miles over 3 years and found nothing in the primary zone. Small pieces of wreckage confirmed to be from MH370 eventually washed up on beaches across the Indian Ocean, from Réunion Island to Mozambique to Madagascar. But the main fuselage, the black boxes, and any definitive answers about what happened remain on the ocean floor somewhere in an area larger than Pennsylvania. The evidence shows a clear pattern across ocean disappearances. First, radar coverage over water is extremely limited. Land-based radar typically reaches only about 200 miles offshore. Beyond that, aircraft rely on position reports and satellite communication, which can have gaps. Second, emergency beacons attached to life rafts and the aircraft itself often fail to activate or transmit in high-impact ocean crashes. When Air France 447 hit the water, none of its emergency beacons successfully alerted rescue services. Third, black box underwater locator beacons have a limited range and battery life. The pingers can only be detected from about 2 miles away under ideal conditions. In the deep ocean with strong currents and background noise, that range shrinks dramatically. After 30 days, the batteries die and the boxes go silent. Fourth, ocean currents and marine life rapidly disperse wreckage. Floating debris can travel hundreds of miles within days, creating massive search areas. Heavier pieces sink at different rates depending on their density and drag, scattering across miles of seafloor. The data is verified through multiple sources. Satellite companies like Inmarsat provided technical analysis of their automated ping data for MH370. Ocean drift modeling used by Australian authorities was peer-reviewed and published in scientific journals. Wreckage authentication involved forensic examination comparing serial numbers and manufacturing marks to Boeing production records. Not everyone accepts the official conclusions about ocean disappearances, and some skepticism is warranted given the lack of physical evidence in cases like MH370. Some aviation analysts have argued that the search area calculations for Flight 370 relied on too many assumptions about fuel range and flight speed. If any of those assumptions were wrong by even a small margin, the actual crash site could be hundreds of miles from where search teams looked. Other experts point to potential gaps in debris recovery. Despite years of beachcombing along predicted drift paths, only 33 pieces of debris have been found and confirmed or assessed as likely from MH370. Some researchers expected more wreckage to wash ashore based on drift models. There are also questions about why certain safety technologies aren't mandatory. Underwater locator beacons could have batteries lasting 90 days instead of 30, giving search teams more time. Black boxes could eject and float on impact rather than sinking with the wreckage. Satellite tracking systems could ping locations every minute instead of every hour. None of these technologies are required by international aviation regulations, largely due to cost and certification complexity. The uncertainty isn't about conspiracy. It's about the massive scale of the ocean and the technical limits of search technology. Even with the best equipment and unlimited funding, finding wreckage in deep water is like searching for a car in an area the size of a continent, in complete darkness, with only sound to guide you. Behind every ocean disappearance are families who never got closure. Parents, children, spouses, and friends are left with an absence that has no grave, no final goodbye, no confirmed explanation. The lack of physical evidence means no burial, no ritual, no end to the questions. For the families of MH370 passengers, the uncertainty became its own form of suffering. Some refused to hold memorial services, clinging to hope despite all evidence pointing to loss. Others fought for years to keep search efforts active, funding private expeditions when government searches ended. The psychological term for this is ambiguous loss, a grief that cannot properly begin because there's no confirmation of death. The human cost extends to search crews and investigators who spend years hunting for answers they may never find. Oceanographers, Navy personnel, and aviation experts dedicate careers to these mysteries, knowing that each case represents real people who deserve to make it home. Think of the ocean as a planetary-scale barrier to visibility. Unlike land, where wreckage leaves scars you can photograph from satellites, water closes over impact sites within seconds. The physics are unforgiving. At cruise altitude, a plane is traveling at roughly 500 miles per hour. If something catastrophic happens, pilots have minutes at most to communicate, descend, and attempt an emergency water landing. Often, there's no time for any of those things. The depth compounds the problem. The average ocean depth is over 12,000 feet, but parts of the Indian Ocean and Pacific exceed 35,000 feet. Deeper than Mount Everest is tall. At those depths, water pressure is immense. Wreckage can be buried under sediment, and underwater terrain is as complex as any mountain range. Modern submersibles and sonar can map the bottom, but it takes months to survey even small areas. This matters beyond aviation. The same tracking gaps that let planes disappear also affect maritime shipping, fishing fleets, and military operations. The ocean remains the least monitored environment on Earth. We have better maps of Mars than of our own seafloor. Every ocean disappearance exposes how little real-time awareness we have over 70% of the planet's surface. The broader lesson is about the illusion of total connectivity. We assume modern technology means nothing can truly vanish anymore. Ocean disappearances prove otherwise. They show that despite satellites, despite GPS, despite instant communication, there are still vast spaces where we go blind. Here's what we know for certain. Planes disappear over oceans because radar can't reach far offshore. Satellite tracking has gaps. Emergency beacons often fail on water impact. And the ocean is so deep and vast that wreckage can stay hidden for decades or forever. We know from recovered black boxes like Air France 447 that technical failures, weather, and human factors all play roles. What we don't know is the specific fate of dozens of aircraft still missing, including MH370. The pattern is clear, but each case carries unique mysteries. Now the question becomes whether the aviation industry will close these gaps before the next disappearance. In the near term, expect expanded satellite tracking mandates. The International Civil Aviation Organization has recommended that all commercial aircraft transmit position data at least every 15 minutes, with 1-minute intervals during emergencies. Implementation is uneven, but major airlines are adopting these systems voluntarily. Search technology will improve incrementally. Autonomous underwater vehicles are becoming cheaper and more capable, able to map larger areas of ocean floor without human crews. Private companies are developing better battery technology for black box beacons, potentially extending their active signaling period to 90 days. The MH370 mystery may see renewed search efforts. Malaysia has indicated openness to new proposals if credible evidence suggests a specific search location. Ocean Infinity, a marine robotics company, has proposed another search using advanced autonomous submarines. Whether that search happens depends on funding and political will. What's less certain is whether the industry will mandate the most effective safety technologies. Ejectable black boxes, real-time video streaming from cockpits, and longer-lasting emergency beacons all exist but remain optional. The cost-benefit calculations often favor the status quo until another high-profile disappearance forces change. The ocean keeps its secrets better than any place on Earth, and until tracking technology closes every gap, planes will continue to vanish into the blue. Each disappearance pushes the boundaries of search capability and forces difficult questions about how much safety is enough. If you want to understand another mystery where the ocean plays a central role, watch The Strange Physics of Deep Sea Pressure. Why Ships Implode. It explores the same crushing depths that hide aircraft wreckage and why recovering anything from the deep ocean is one of the hardest challenges in engineering. This script synthesizes information from official aviation safety investigation reports, oceanographic research, satellite data analysis, and credible news reporting from 2009 to 2024. As investigations continue and new evidence emerges, some details may be updated. No speculation has been presented as confirmed fact. All references to victims and families are made with respect for their privacy and loss. Autonomous underwater vehicles and submersibles continue to explore the ocean floor, slowly revealing secrets hidden in extreme depths. Mannequin policymakers discuss next-generation tracking standards, weighing cost against safety, aiming to close the gaps that allow planes to vanish. A lone mannequin sits among floating holographic displays of flight paths and wreckage data, reflecting on the challenges of monitoring the vast oceans. A solitary mannequin stands on a cliff edge watching contrails fade into twilight over the sea, symbolizing both loss and hope for better tracking in the future. A plane's silhouette vanishes into a glowing blue horizon above calm ocean waters as the sky darkens to night, leaving the ocean's secrets intact.